Hello, everyone. In today's teaching lesson, I want to look at staffing for a bank branch. Okay, we're going to calculate staffing solutions at a branch of a bank using Python. So basically, we're going to look at patterns in the data, any kind of Monday through Friday patterns, and Saturday. Is Saturday different from the weekdays? I think it is. I can pretty much guarantee it is. We're going to see some scenarios around that, and we're going to make some predictions eventually about how many people will be coming into the branch and how many people we need to staff at the branch to handle the demand for each weekday and on Saturdays as well. And then we're going to try to determine when the next customer is going to enter the bank using our Laplace methodology. Okay, so the benefits to this are pretty obvious. You want to staff appropriately at your enterprise, and this can be a bank, it can be an airline staffing, hotel, restaurant, it can be anything, right? I have another video that I already posted about staffing optimization. So this would be like a preliminary step. How many people would you pick to staff at the operation of whatever kind of business you're running, right? And the other example I've posted already is more about how to optimize the staffing process, right? So similar approach, but kind of different perspective on things too. So we're going to look at the following things: peak and off-peak hours, Poisson distribution to try to predict customer arrivals, exponential distribution for service durations. How long does it take to handle one customer, right? It's not going to be 1 minute probably, although it could be. That's a pretty quick transaction. It's probably not going to be several hours, although perhaps that scenario could occur too, but most likely it's going to be some combination in the middle, right? So we'll look at that. We want to get granularity of timing. We want to see varying rates based on seasonality or trends over time. We want to incorporate any kind of variability and store hours, any kind of specific customer behavior on Saturdays versus weekdays. We want to understand that. And then overall service duration and how well are we handling the demands that occurs, right? So we are going to go ahead and import a couple basic Python libraries here. We are going to create a range of hours from 9 a.m. until 6 p.m. So this is 24-hour format, 9 a.m. to 1800, right? 1800 hours is 6 p.m. And we're going to store everything in a list called data. You can tell this is a list object by the square brackets, okay? And we're going to look at peak hours and non-peak hours. And again, look at the differences in duration of customers coming into this bank branch Monday through Friday versus weekends, right? Saturday, the bank is closed on Sunday. If you happen to be open, if it's a restaurant or hotel or something like that, then you would include Sundays as well, okay? So we're going to look at 1 year time duration. This is, for me, it is the, August is over, actually. This is the beginning of September. I did this example a couple of days ago. So I was looking at the end of August and going back into the end of August last year. So August 31, 2024, going back in time to August 1st, 2023. So just over 1 year, about a year and a month or so. And we're going to look at the dates and then the hours of those dates. So here we have the code. I'm going to hit Control Enter to run it. And I will share all this code with you. I do this in all of my videos. I describe what's going on in the video, and then I save the code in an HTML format. You can download that, double click it to open it, and you'll have all the source code. So you don't have to take notes. You don't have to be too concerned about all the details and all the nuances of what's happening here. You'll have plenty of time to download the file and explore on your own, take it apart, put it back together, and understand how all this stuff works. Okay, so here we have the data frame. We have the shape is 40,000 records, 40,254 in 4 columns. We have date, arrival time, duration. This is the number of minutes that it takes to service the customer, and then the hour of the day that the customer is being serviced. Okay, and we have the head and the tail for this. So I think this looks good. Let us proceed on. We are going to, let me see here, what is this? I think this is the graphing part. I did this a couple of days ago, then put it away. Just coming back to it now. So let me take a look. Okay, we're doing aggregation. So we're aggregating all the counts for all the dates. How many customers are coming into the branch on the day the different days over a period of time, right? And then we're going to make this a little bit easier to interpret. So instead of just dates on calendar, I want to look at the day of the week, and is this Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday, right? So we are going to do some feature engineering here. This is when you create new features from existing features. We're going to get the day of the week listed next to all the dates, right? So we have the date, the number of customers serviced, and then the date of the week. So this is a little bit more intuitive than just looking at a calendar date. Okay, and already you can see Monday through Friday, pretty consistent, a little over 100 customers. Saturdays is slower, right? Like people are relaxing on the weekend, they're traveling, maybe going to the beach. If it's summertime, if it's winter, maybe they're going skiing, maybe mountain biking, running, who knows what. But people aren't necessarily conducting their banking business on the weekends. So this is presumably going to be slower, in some cases half what it is on the weekdays, in some cases less than half on Saturdays, right? So Saturday is a slower day, and the bank isn't open quite as long either, right? The hours are somewhat limited. I think it's 10 a.m. to 2 p.m. instead of 9 a.m. to 6 p.m. Okay, so in this case, we're going to, so we have all our data prepared, aggregated. We did the feature engineering, so we have the day of the week. That's very helpful. Now we're going to go ahead and create some plots. Control Enter to run this. Okay, we see the asterisk running and the hourglass at the top. It just stopped. So now we have the date on the horizontal axis and the counts of customers on the y-axis, and we're going to color each chart based on the day of the week. So let me scroll down and see what this thing looks like. Okay, and we have the jagged lines. It's somewhat random over time, over the days of the week. Tuesday, Wednesday, Thursday, Friday. Saturday is always lower, right? That's pretty predictable. And then Monday is pretty similar to all the other 4 days, right? And we have a slider here, so we can go ahead and move this over and zoom in. This chart is interactive. We can go ahead and zoom in to the left and to the right and focus what we're viewing over here. And of course, we have the pop-up, so when you mouse over this, you see all the details. You see the arrival counts. You see the day of the week is colored a specific color, right? And you see in the pop-up item here in the tooltip, you see the date, the day of the week, and the counts of the items. And again, I can scroll. Oops, not sure what that is. Okay, let's get rid of that. Let's just get the scrolls over here, and we can go left and right with the scroll bar, and then zoom in and get more granular details about what we're looking at. So that's what really makes these Jupyter notebooks stand out. And I love working with Plotly too, because this is interactive. So you go over the chart with your mouse and you have all the details. You can zoom in, zoom out, focus in on specific details, whatever you need to get to. So it's very interactive, very user-friendly for your clients, for your stakeholders. This is a great way to present data in an interactive and actually kind of fun format to be able to use. And it's very practical too, right? Very practical and useful to be able to have this kind of control on charts. A lot of charts that we see are not interactive, right? They're very static, a little bit boring. If you want to get details about the chart, it's literally impossible to do that, right? But with these plotly charts, it's the opposite. Everything is highly interactive, right? So I like working with these a lot. So I'll share all this code with you when I post a video later today. Let's scroll down to the next cell and see what's going on there. So move down. Okay, now we have plots based, individual plots instead of a comprehensive plot with everything. Control Enter to refresh it. We have individual plots broken out. So different means the same end. You might have a preference for the first, you may have a preference for the second. It doesn't really matter. The story is the same. It gets the point across. Maybe the other one is slightly better because you can see that Saturdays are historically less customers, less demand, lower frequencies of people coming into the branch. And this one, you can still tell on the y-axis, we're looking between about 40 to 70 on the y-axis, so that's pretty obvious. But if someone wasn't paying attention, they might think that all 6 plots are pretty much the same, when in fact, Monday through Friday, the minimum is maybe down to 100 or so, and the maximum is up to about 160, and Saturday is different, right? So just be aware of that y-axis and this view, right? Could be a little bit misleading, but hopefully it's not. So let's go ahead and run the next cell. Control Enter to refresh this, and we are going to look at an example of Facebook profit, and we're going to make predictions into the future what we can expect for customers coming into our branch. So in the past, I wasn't a huge fan of Facebook profit, but I've done a couple videos recently where I did try this model, and the results were very impressive. So I have to change my mind. I still not like this at all, to be honest. But in the last couple of weeks, I've been playing around with this. I really have a new take on this model. So given a scenario, can produce very impressive results. You really have to try several different models and see what the outcome is. This is why it's called data science, right? Because we try experiments. We don't know what to expect when we kick it off. When we initially run these things, we can create a hypothesis and we think we know what's going to happen, but you never really know until you run it and see what the outcome is, right? So that's why we're doing this. So we have profit. We're making our predictions. It's kind of nice now. You have the date in the first column, the trend, the y hat lower. That's what's being predicted. Okay, so you have the lower threshold, the upper threshold for the date, because again, we don't know exactly how many customers are coming in. That's impossible to know that, right? But we can have an estimate and predict with a high degree of confidence, very accurately, how many customers are going to come in. So on this date, 8/1/2023, we know what the trend is historically. We know what the lower threshold is and what the upper threshold is going to be, right? And we have those bounds, and we're highly confident that the number of customers coming in is going to stay within those bounds, unless there's some kind of run on the bank, or everybody is sick with COVID and everybody is stuck at home. Then maybe there's no customers coming in. But most likely, you're going to have a certain upper and lower threshold of customers coming in. Okay, you have the trends over here. Upper terms weekly lower, so you have the highs and lows. So this is what profit makes for you, and it's very nice. All we have here is the arrival data frame. That's the initial data frame that I created. That's what we're working with. We have the date and the arrival counts. So just based on that, just based on the date and the counts, Facebook profit, the model here, profit, produced all of these results. So it's actually doing a lot of work. It's doing a pretty huge lift. Let us go down a little bit further. Okay, and we're going to plot the results. So Control Enter, as always, to refresh this. We'll see the forecasted plot into the future. Okay, so this looks pretty nice. So the low is about 60. The high is maybe about 160. The black dots are showing us a few outliers here, and we can see the bouncing, the trend over time. It's pretty consistent. The 60 here is getting pulled down because of the Saturdays, right? We might want to break out Saturday and just do that slightly different. But I think this is okay. This is achieving the objective here. So this looks pretty nice. Let's go down a little bit more and see what kind of predictions profit is making for us. Okay, so the next 30 days, that's what we're looking at. Now it's actually September 3rd. I created this model right at the end of August. So August 31st, I built this. Just refresh it now. So the next 30 days, we're looking at September 1st to September 30. So Control Enter to refresh. And here's the prediction, right? So I like this a lot. And this is exactly why. If we go to 9/7, we see 56. This number dips down. Otherwise, we have about 130 customers each day. So pretty consistent, 131, 130. 9/14 dips down. Okay. 9/21 and 9/27. So no, 9/28. So these are all multiples of 7, right? 7, 14, 21, 28. Why is it doing this? Let's go over here and look at the calendar. I think I know why. So that's what I thought. All right, just like I suspect. 7, 14, 21, and 28 are Saturdays, so the numbers are trending down on the Saturdays because historically that's what it's been. We're making predictions into the next 30 days. What's going to happen? Getting about 130 customers each weekday, and on Saturdays we're getting around 56, right? Pretty much 56. That's fairly consistent. So this is a very good estimate now of how we can staff our bank branch, right? So now we have historical numbers, we have forecasts into the future, we know how many people to staff. We'll look at that in just a minute. Let me look at, okay, this is a service time per customer, 15 minutes in terms of hours. Yeah, so it's about 50 minutes per customer to service a customer. Now, again, some of these are going to be faster, some will be slower. We're estimating probably 15 minutes. Okay, Control Fresh to get this updated. And we know how many employees we need to staff each day. So again, Saturdays are a little bit different. We're getting 5 employees, weekdays and Saturdays. Saturdays might be a little bit overstaffed here. We could play around with these numbers here. But I love how Facebook Profit takes these dates into the future for the next 30 days. The Y hat is a prediction, number of customers coming in, and then how many employees we need to staff this branch to be able to handle the demand that's coming in, right? I live in New York City. I think this is very realistic for New York City. Now, if you live in a small town in a rural area, maybe in the Midwest or who knows where, like some kind of rural town with a minimum number of people, 5 might actually be too many people. Maybe you just need 2 in the branch. Maybe you just need 3 in the branch. So it really depends on your geography. We could do this analysis a bunch of different ways. We can look at density of populations in different geographical regions. I didn't actually do this. I'm just trying to keep it simple and straightforward here. But I think 5 in New York City is very realistic. If you're in a very rural area with a couple hundred people, the scenario is going to be different. You could probably get away with 2 people, maybe 3 if it's suburbs, right? A little bit more dense population. But in a metro area, I think 5 is a good starting number. And again, you can take this to your manager. You can take this to the operations people, to the to management team, to the leadership team. This is a good way to start a conversation and say, does this make sense to you, right? We're using data science to make these predictions, but let's apply common sense as well. Talk to the management team. Maybe talk to HR. Does this make sense to you? Talk to a couple leaders in your organization and ask them literally, does this make sense? This is a good conversation point. This is a good starting point. Does this make sense? Do we need to make adjustments? Again, in New York City, I think this is pretty accurate. In your rural area or suburban area, it might be slightly different. Let's look at a different example here. This is a REMA model. It's going to do something similar to what Facebook was doing, making predictions into the future based on historical estimates, right? Or historical actuals, actually. So historical numbers. So this is an ARIMA model, a time series model. We're looking at time series data. Anything that's temporal or has dates and transactions over a period of time is time series or temporal data. So ARIMA ran. We got the results. In some cases, ARIMA is great. In some cases, it just doesn't perform very well. So a classical statistical type of model. Profit is more like a machine learning, sort of a deep learning, almost AI kind of solution. ARIMA is not AI at all. It's just a classical statistical predictive model. So in this case, it says 9/6, 59 people are coming to the bank, 9/12, 67, and 9/18, 73, and 9/24, 79. So I can already tell that ARIMA is making some big mistakes here because we know 7, 14, 21, and 28 are the Saturdays. Those are the weekend days. So those days should be staffed lower because the demand for customers is lower, right? Could be half in some cases, almost 1/3 in a few cases that we saw. So I don't like what this ARIMA model is doing right off the bat. I'll tell you, I would go with profit over ARIMA. Let's look at another example just for sort of peace of mind here. Yeah, put this in notes too. Yeah, like the ARIMA model is really coming up short. I don't like the performance. It's saying that weekdays, the customer demand is going to be lower, but we know that's not true. We know it's going to be lower on Saturdays, right? Weekdays are pretty consistent, about 130 or so customers, pretty consistent. So here's another solution using a random forest regressor. Again, this is time series data, and it's all numerical, so we can use a regressor. If it was labeled data, we would use a classifier, right, to try to classify the outcome. Now we're trying to look at regression, or use regression to solve the problem. We have the X and Y variables, so the arrival counts is what we're trying to predict. That's going to be the Y, or the Y hat, it's called. I have a fancy name for the predicted variable. So let's look at the outcome again. We have the date. The Y hat is the predicted value of customers coming in and the number of employees that we need to staff that branch location, that bank branch location. So it's telling me September 1st, 58. That seems wrong to me. That seems like, first of all, I think that was holiday. That was Labor Day, right? So that is kind of an outlier. We'd have to handle that slightly different. Let's see if it got the weekend right. 57. Okay, so we know 7, 14. Let's go down to 14. And we see on 13, which is a Friday, they say 58 customers, Saturday 130, so that's wrong. So again, it's kind of doing what the ARIMA model is doing. The approach is very different. Random forest regressor is a machine learning model, and ARIMA is a classical statistical time series analysis model. But it's messing this up, right? It's getting these dates wrong. It says 9/19, 57 people are coming in. We know that's wrong. We know it's 9/21 is a Saturday, and 9/28 is a Saturday. Now it's almost thinking that this is a Saturday, right? And it says fewer employees are required to staff the branch. That's just not true. It's not true, right? So I think in this case, the Facebook profit model outperforms the ARIMA model and the random forest regressor, and it's totally fine, right? Usually we try a couple different approaches, see what the outcome is, and then we pick the best model given this data set that we're working with. And again, you never know when you start what the outcome is going to be. You have to run several models and see how each performs on this data set. If the data was different, maybe the ARIMA model would outperform profit. And if the data was even slightly different, maybe the random forest regressor would outperform the other two, right? So you have to try a few different models and see what happens, and then pick the one that works the best for you, okay? Let's look at another example here. So now we are scaling the data again, training, testing, splitting, setting the y dependent variable. I've done a bunch of videos about data science and machine learning. So the x is always the independent, and the y is the dependent. So we're trying to predict how many customers are coming in. Let me hit Control Enter. So now we're scaling the data or normalizing it or standardizing it to handle any outliers and any kind of data points that could be anomalies. We're trying to handle these more gracefully and see again if the model can make these predictions. But even when we normalize all the data, in this case, it still can't get it right? It still thinks that Friday, the number of people coming in is going to be less, but we know it's going to be Saturday, right? So again, even when we transform the data, the model still can't pick up the nuances. It's probably overfitting the data, right? And it's learning the noise in the data, but not the nuances. We want the model to learn the details of the data and ignore the noise. I think it's overfitting and learning too much here. So that's fine. It is what it is. We have our results. Profit wins. In this case, it predicts the most likely scenario of the number of people coming in, about 130 on weekdays, about 60, maybe mid-50s, between 50 and 60 on Saturdays. So we know how many people we have to staff at this establishment, and management's happy, operations people is happy, the HR people are happy, and everybody's happy here. So let us look at another example here, and we'll be wrapping up pretty quickly. So the Laplace distribution can help us to understand when the next person is going to come into your establishment, whether this is an airline company, a train company, people taking your train to work or for a trip, or whether it's a hotel or a restaurant. In this case, we're looking at a bank branch. Okay, so Laplace helps us understand when the next person will come into your establishment, right? And they'll need help with some type of transaction. Okay, so Laplace is great for this. It says 21.87 minutes until the next customer arrives. So it's a pretty simple calculation here. You can Google it and look up online. I don't have time to get into all the details of all these things, but again, that's why I share the code with you, so you can hit the pause button. You can take your time, understand, download the source code that I'm going to share with you, and understand how all this stuff works at your pace, right? We go through these things pretty quickly, but it's just to introduce the topic, to explore different ideas and concepts, and then just show you ultimately what can be done with Python. Maybe people don't know. I'll tell you a true story. I was working for a bank a few years ago, and they had a massive Excel sheet. It was at least 40 tabs long. A tab is a worksheet in Excel. And the thing was just a behemoth. It was very complicated. I thought it was way over engineered. And I talked to a couple people on the team. I said, you have a 40 sheet Excel file here. Nobody totally understands how it works. So there's a couple people that maintained it. Even the people that created it, over time, it got more and more sophisticated, more complicated. And it was so like Wild West, out of control. Nobody fully understood the intricacies and all the details of this model. It was very cumbersome to work with. It was very complicated. but that's what they use. I said, let's go with a simple solution. I'll create a Python workbook for you that you can just run and ingest your historical data. So in this case, I created data. I don't have the bank's actual data, right? That's all confidential and classified. I don't have access to that, so I created it. But I said, I'll use your data, import that, and create the model for you. It'll be a few lines of code, easy to set up, very easy to maintain, easy to share with stakeholders and understand what's going on. It's very transparent, 100% open source, transparent, and simple. And they just didn't grasp the concept. They said, no, we'll use Excel. We've always used Excel. This is what we're going to use forever and ever and ever. And I talked to a couple of people. I said, this is really over-engineered. It's the wrong approach. Why don't you just take a little while to stop and learn a new technology. It's pretty simple, pretty straightforward, very streamlined, easy to set up, easy to maintain. And I'll do all the work. I'm not expecting you to become a Python expert. I'll do all the work, explain everything, how everything works, and give you notes and share with you how you can streamline this whole process. And nobody could do that. Nobody could comprehend what was going on. And I talked to one guy. I said, why don't you just do this? Like, this is literally done. It took them months and months, I think at least 6 months to set up the workbook, and then it had bugs in it. I said, this could be done in a couple hours, right? And I'll do a handoff and you have everything you need. And the guy said, we can't use Python here. We don't know how it works. We don't have any people on our staff that knows how it works. And I said, why aren't you hiring these people that understand this concept? And the guy looked at me kind of with a little bewilderment, a little confusion on his face, and he literally said to me, we're not hiring the right people for this job. So that was unfortunate, but let's not repeat the mistakes that this bank was making. Let's do this the right way. You can use Excel for simple little things, even intermediate, maybe complex things, but in most cases, Python is a far superior solution to Excel. You should really consider this. And I'll tell you, it does take a little time to get up to speed. Excel is easy to click around. You can do some simple things pretty quick and pretty easy. But Python is a real solution for real people that want a long-term solution here, right? This is ideal. This is the way it should be done. This is the way it really needs to be done. And if you can't do that, maybe you need to read a couple books or something, get up to speed, because Excel is a great tool for some things, but it's a horrible option for a lot of things out there. So let's just be aware of that and not repeat the same mistake that this bank was making. So in conclusion here, what are we looking at? We're doing forecasting of customers coming into this establishment, right? This enterprise can be anything. It can be a hotel, front desk, housekeeping. It can be some travel agency. It could be a cruise line. It could be a restaurant, retail store, healthcare, people coming into the hospital, any kind of event venues. It could be a stadium for NFL and Major League Baseball, NBA, hockey, right? And NHL. It could be anything, right? Any kind of venue where people are coming in to your enterprise and they need help with something, either to watch a ball game or going to a hospital or going to a bank branch. These solutions are pretty comprehensive, very exhaustive. You can cover almost any kind of scenario you can imagine when you're working with customers and counting the number of customers coming in and how do you staff that establishment based on actual historical data. This solution will help you get there, right? So that's pretty much it. Hopefully this was enlightening. Hopefully you learned something new. I learned a couple of new things putting this teaching lesson together. So hopefully you did too. Okay, thank you so much for your time and have a wonderful day. Goodbye, everybody.